Irodov problem 1.128 on the board. A small body of mass m moves in the reference frame rotating about a stationary axis with a constant angular velocity omega. What work does the centrifugal force of inertia perform during the transfer of this body along an arbitrary path from point 1 to point 2, which are located at the distances r1 and r2 from the rotation axis? Okay. So let's suppose this is the rotation axis. Okay. So this axis is rotating with a constant angular velocity omega, and there is a small body of mass m which is initially at r1 distance from the axis, and then it reaches another point which is r2 distance from the axis, and it is said that this can take an arbitrary path from here to r, the distance r2. Okay. The question is, what is the work done by the centrifugal force of inertia in the transfer of the body from this point to that point? Okay. So first of all, the centrifugal force of inertia in a frame of reference which is rotating with a constant angular velocity omega will be m r omega square. Okay, and this is a fictitious force. It is acting like this. Okay. Now, if you have trouble understanding why this is mr omega square, then maybe I can just quickly do a thing for you. So, in a circular motion, if the velocity of a particle is v, the radial acceleration is v square by r. Okay. Now, in this case, the frame itself is rotating. So, you can think of it like the radial acceleration of the frame or centrifugal acceleration on any body in that frame is minus ar. Okay. Now, v can be written as r omega. So, this becomes r square omega square by r. So, therefore, this is r omega square. So, the radial force is MAR, so it is mr omega square. Okay. Now, let's suppose at an arbitrary distance r, okay, the centrifugal force being experienced by the body is mr omega square, and then after a small interval of time it moves to a distance r plus dr. Okay. So, to move this distance dr, so that dr is actually in the horizontal direction. Now, we are only concerned in the horizontal direction in the displacement along FC, because any displacement, let us say part of this, if I enlarge that, so there is some displacement that is happening in the horizontal direction, and then there is some displacement that is happening in the vertical direction. Okay. Now, because the force is always acting this side, you remember work done, we can say either this is F dot ds, it's the dot product. We can think of it as force in the direction of displacement or displacement in the direction of force. In this case, we will think of it as displacement in the direction of force, which is always dr. Okay. So then we can write the work done by the centrifugal force is F dot dr, and it's from R1 to R2, but this we can reduce it as integral mr omega square into dr, R1 to R2. Okay, and then it's simple. M omega square is a constant. This integration becomes r square by 2. This is from R1 to R2. So this becomes m omega square by 2 R2 square minus R1 square. So that is the total work done by the centrifugal force of inertia. Okay.